Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 14. This is Section 13.4. It's problem number 14. It says, draw the graph of f of x equals x cubed minus 3x squared minus 9x minus 20. And be sure to label the x and y coordinates of any critical points. So to start the process off, we're going to find f prime of x, the first derivative. So f prime of x equals, the first piece of my function is x cubed. It gives me a derivative of 3x squared. And again, that comes from the exponent of 3 coming down times the number in front, which isn't written, but it's assumed to be 1. So the 3 times 1 gives me a 3 in front. My exponent of 3 is reduced by 1 from a third power down to a second power. The next piece of my function is minus 3x squared. That gives me a derivative of negative 6x to the first. And again, that's coming from the exponent of 2, coming down times the number in front of minus 3. 2 times minus 3 is minus 6. X to 1 less power, that second power drops down to a first power. Then I have the minus 9x. Its derivative is minus 9. Again, when you have something with just an x to the first power, the derivative is the number in front. So minus 9, again, pay attention to the sign. And the last piece, minus 20, it has no x with it, so its derivative is 0. So my derivative is f prime of x is 3x squared minus 6x minus 9. So the next part of the process, we're going to take that answer and set it equal to 0. So I'm just going to take what I got, 3x squared minus 6x minus 9, and right next to it equals 0. After that, I solve for x. So to solve for x, I'm going to need to factor this because of my x squared that's involved. I'm going to look for 2 factors or 2 sets of parentheses. And before I start breaking down my parentheses, notice each piece of the equation that I have to solve has a times 3 in it. So let's put a 3 in front of a set of parentheses and factor out a 3. So the 3x squared is going to put an x squared inside the parentheses. The minus 6x will put a minus 2x inside the parentheses. And the minus 9 will put a minus 3 inside the parentheses. And you can verify that that is the right way to factor it. The 3 in front times the x squared inside will make a 3x squared. The 3 in front of the parentheses times the minus 2x in the parentheses will be minus 6x squared. And the 3 in front of the parentheses times the negative 3 inside the parentheses will make a minus 9. Again, you have to pay attention to the signs, very important. And now what's left in the parentheses, I can break into 2 sets of parentheses, or 2 factors. You can leave the 3 in front and make 2 parentheses, x, x. And I want to factor this so I have 2 numbers that multiply to give me a minus 3, and they add together to give me a minus 2. So the numbers that would do that for me would be negative 3 and positive 1. And you can check that. If you FOIL this out, the first inner outer last multiplication, and combine your like terms, sure enough, you will get x squared minus 2x minus 3. You can always check it if you're not sure. Now, each set of parentheses, or factor, will give me an answer. The first factor of x minus 3 produces an answer of x equals positive 3. Again, that value of x equal to positive 3 will make the equation true. If you put in a 3 for x, you'll get 0 equals 0. It makes the equation true. And the other factor, x plus 1, will give me a solution of x equals negative 1. Again, if I put in a negative 1 for x, it makes the equation true. You get 0 equals 0. So I have 2 answers. X is 3 and x is minus 1. So those are the x coordinates of where I would have a critical spot on my graph, or where I have a horizontal tangent line. So for each one of those, I have to find the y coordinate. So I have a critical spot over 3, and up or down how much I have to find out. So what I'm going to do is first take the 3 and put it in for x in f of x. Again, not f prime of x. If I put in a 3 in f prime, I know the answer is going to be 0. That's what we solved here. I want to put it in f of x and find the y. So f of 3 will be, the x cubed will produce a 3 cubed. Minus 3x squared will be minus 3 times 3 squared. And then minus 9 times x will be minus 9 times 3. And then there's a minus 20 on the end. So now Do the math. There's a lot of 27s going to come out here. 3 to the third, 3 times 3 times 3 is 27. Now the next piece, I have to do 3 to the second power first, which is 9, times the minus 3 in front. 9 times negative 3 is negative 27. Then the next piece, minus 9 times 3 is going to be another negative 27. Then I have minus 20. So 27, 27, 27, and 20, but you have to watch the signs. The first pair of 27s, one is positive, one is negative. So let me just cancel those off and get rid of them. And then I have a negative 27 and a negative 20, so that's going to be negative 47. So I have a critical point with an x-coordinate of positive 3 and a y-coordinate of negative 47. So I can go ahead and put that on the graph now. And because I tried the problem before I put it on the whiteboard, I knew that running it one at a time, I'd have to go down too far to run one at a time to hit my negative 47. So ahead of time, I set up the graph and I ran it by 5s. So if I go over 3, I don't have 3 exactly on my graph, but by eye, it's a little before the 5. And I don't have negative 47 on my graph either. But by eye, if I go right between negative 45 and negative 50, it'd be negative 47.5. So I'll go slightly lower than exactly the halfway point by eye. And figure again by eye over 3. So over about 3, a little before the 5, and down negative 47, again by eye. So this is positive 3 for the x-coordinate, negative 47 for the y-coordinate. So there's one of my 2 critical points. One critical point, again, had an x value of 3. We found the y value that goes with it is negative 47. Let's do that same process for the other critical point that has an x-coordinate of minus 1. So now do the same thing. Take the minus 1, put it into f of x, do the math, find the y that goes with an x of minus 1. So f of minus 1, going back to f of x, I'm going to have x cubed. That will make a minus 1 cubed. Minus 3x squared, so minus 3 times minus 1 squared. Then minus 9 times x, so minus 9 times minus 1. And then minus 20. So let's do the math for that. So minus 1 cubed, because of the odd power, it's going to come out to minus 1. Minus 1 to the third is minus 1 times minus 1 times minus 1 again, comes out to negative 1. The next piece to evaluate is 3 times negative 1 squared. Do the negative 1 squared first. You'll have positive 1 times the minus 3 in front. Positive 1 times minus 3 is negative 3. And then I have minus 9 times minus 1. The minus times the minus will cancel. I have positive 9 and minus 20 on the end. So if I have minus 1, minus 3, minus 20, that's minus 24 and positive 9. So minus 24 and positive 9 is minus 15. So I have another critical point with an x-coordinate of minus 1, a y-coordinate of minus 15. So I can go ahead and plot that on the graph. So minus 1, again, I don't have a minus 1 of x written on my graph the way the scale is set up, but by eye I can see it's a tiny bit to the left of the 0, 0 point. And now minus 15 I do have on my graph, so right about where the number is would be back 1, down 15. So let me actually just get rid of the number scale part of it. Go back 1, down 15 would put a critical point right there. Back 1, down 15. So I have my 2 critical points plotted on the graph. Again, when I say critical point, it has a horizontal tangent line or a flat spot. So I know it flattens out here. And since I know these 2 are connected, I'm going to have a flat spot. It's going to come down, flatten out. And now, most likely at each critical point, there's going to be a change in direction. But as we've seen from previous problems, sometimes it can flatten briefly and continue in the same direction. So you want to see whether or not that's what's happening. So what I'd like to do, I have the height at negative 1. I'd like to see if I go to negative 2, if I'm a little above or below that critical point, to see if it flattens out and keeps going the same way or flattens out and turns around. So I know what happens when x is negative 1, my height's minus 15. Let's see what happens when my x is negative 2. So to do that, put negative 2 into f of x. So f of negative 2 equals, start with x cubed, which will make a negative 2 cubed. Next piece is minus 3x squared, so minus 3 times negative 2 squared. The next piece is minus 9x, so minus 9 times negative 2. And then minus 20. And if we do the math, negative 2 to the third, negative 2 times negative 2 times negative 2, it multiplies out to be minus 8. And the next piece, negative 2 squared, negative 2 times negative 2 is positive 4, but times the negative 3 in front, 4 times negative 3 is negative 12. And then negative 9 times negative 2, the negative times negative cancel, you get positive 18, and there's a negative 20 on the end. So negative 8 and negative 12 is negative 20, and another negative 20 is negative 40, and positive 18. So negative 40 plus 18 will be negative 22. So if I go back to, again, right in between is minus 2.5. So go not quite right in between the 0 and the minus 5. So if I'm at negative 2, I'm down negative 22. So I don't have negative 22 on my graph, but approximately between negative 20 and negative 25 would be negative 22. So back to down 22. What it's telling me is after my critical spot, there is a change in direction. So it's going to flatten out briefly and come back down, down, down. So that's one end. So I have to figure out the same thing at my other critical spot. When I go over 3 and down 47, what happens if I go over 4? Is the height of my function a little above or a little below that critical spot? So let's put in a 4 and see what happens. So again, that'd be 4, positive 4. So put it in for x and f of x and see what type of height you get. So f of x will become f of 4. The x cubed becomes 4 cubed. Minus 3x squared will be minus 3 times 4 squared. And then minus 9 times x will be minus 9 times 4. And then minus 20 on the end. So let's do the math, see what type of height we get. So 4 cubed is 4 to the third. So 4 times 4 is 16 times the third 4 is 64. 4 cubed is 64. And now minus 3 times 4 squared. The 4 squared, 4 times 4 is 16 times the negative 3 in front. So 16 times negative 3 is minus 48. And now I'm going to have negative 9 times 4 is negative 36. And then I also have negative 20. So now, if I put my negatives together, so negative 48 and negative 36 would be negative 84. And then negative 20, so negative 84 and negative 20 is negative 104. And then positive 64. So negative 104, positive 64 would be negative 40. So if I go over 4, I'm down 40, which I happen to have exactly on my graph. So over 4, so I don't have 4 for x, but negative 40 for y I do have right there. So after my critical spot, it flattens out briefly, and it's going to come back up. So that's what my graph looks like.